Hello, this is another kinematics question, this time in 2 dimensions. All the ones so far have been 1 dimensional kinematics, but 2 dimensional stuff is all the same really. We've got a particle moving constant acceleration between points A and B. At A, it's got this velocity, B, it's got that velocity, right? And it takes 10 seconds. So all we're doing in 2 dimensions is, well, I'm going to write it all as column vectors, so I don't have to keep writing I and J out all the time. So I'll tabulate all of this. We've got T, S, V, and A. T, we're saying, is going from 0 to 10. S, well, it doesn't actually give us an origin, so let's put the origin at A, seeing as that's our location at T equals 0. So I'll just write this I is on the top and J is on the bottom. We don't know where it's ended up yet. So that's empty. Our velocity is going from 4, 2 to 7, 6. And now we can fill in a lot of this because we've got the velocity row, which is always a nice one to have. So we can say that the acceleration, change in velocity divided by the time. So we've got 0.3 and a 0.4. And then our displacement, or the change in displacement, but that is the displacement from A, because we've stuck our origin at A, is the average velocity multiplied by the time. So that will be 55 and 40. So just added them up, multiplied by 5. So we've already filled in the table without having to explicitly write out some SUVAT. And it's given us the answer to the first part of the question, the acceleration of the particle, but we want to put it back into the format of the question. So we'll write it as 0.3 I plus 0.4 J meters per second squared. Don't forget the units. So that's done that bit. Find the distance between A and B. Well, we've got the displacement, so we want the distance to be the square root of 55 squared plus 40 squared. So we could go to the calculator, but let's keep our numbers sharp on this. We've got factors of 5 in this, which is the half the time bit that we brought in at the start. So we could pull out a 5, once we've the 5 squared, root that down, and then we'll have root of 121, that's the 11 squared, plus 8 squared. So that is 5 root 185, which is 5 times 37. So 5 root 5 root 37, which, looks a bit more sophisticated. So the distance between A and B is 5 times the square root of 5 times the square root of 37 meters. Again, not forgetting the units. Now we've got to find the average velocity as the particle moves from A to B. Oh, well, that's just easy because, well, either we can just average our velocity numbers, or we can take the change in the displacement divided by the time. But either way, we're getting 5.5 I plus 4J. And velocity, so meters per second. We haven't had to rely on SUVAT equations. We've just talked it through again. Nice question. Doesn't matter. It's in 2 dimensions. We're just doing everything twice and stacking them up in column vectors. So we're still on the same fairly basic introductory kinematic stuff.